Now, today, ladies and gentlemen, we're going to talk and we're going to check out our notes. And you should compare your video notes well, I guess it's your notes that you took on the video with things that I go over here. Because you need to make sure that you are taking good notes on this. Now, today our objectives, our goals, okay? We definitely need to be able to define the mole, okay? Second thing is we need to become familiar with Avogadro's number. And based on your knowledge of Avogadro's number and the mole from the video, you should realize that they go hand in hand. Okay? Hand in hand, they work together. So this is all dealing with our unit, the introduction, the start of chemical quantities. Now, I preached many, many times that if you cannot name chemicals and write formulas, that you're not going to do very good in chemical quantities. And those of you that didn't believe me are going to see that. If you can't name the chemical and write the formula, you're definitely going to struggle with this. Okay? Now, we started talking about masses. If you look at this, the mass of one atom of oxygen is 2.657 times 10 to the negative 23rd grams. So that is a very, 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 and a lot of varies, small number. Well, makes sense, doesn't it? How small is an atom of oxygen? Does it make sense that it doesn't weigh very much? Yeah, okay, that makes sense. So, scientists wanted to have what we call standard, a measurement that's used everywhere. We talked earlier about the metric system. Okay, we talked about how in the United States, we don't use the metric system like they do everywhere else in the world. For example, okay, everywhere in the world goes by kilometers per hour. What do we go by? Miles, okay? If you go up to Canada, you don't buy a gallon of gas. They don't know what a gallon is. You buy a liter of gas, okay? So, we needed to find some sort of a scale. So what we did, what the chemists did, is they came up with the idea of an atomic mass unit and called it AMU. And they said the atomic mass unit is exactly 1/12 the mass of a carbon-12 atom. So here are some atomic mass units for some given atoms. Now, what do those numbers correspond to? Okay, it says hydrogen 1 is 1.00794 AMU. Any idea what that corresponds to? Well, take out your periodic table, because Jacob's going to tell us what, right? The atomic weight listed on the periodic table, right? So look at the little red number in the upper right-hand box of hydrogen. It should be 1.00794. Sound right? What about oxygen? Look at oxygen. 15.9994. Find magnesium. Is that 24.3050? Okay, so see where those numbers correspond to. Now, the mole. The mole. It is the SI, the metric system unit for the amount of a substance. Now, the definition of the mole is the amount of a substance that contains as many particles as there are in atoms of exactly 12 grams of carbon-12. Okay? Here is the little guy. That is actually a mole, not the mole we're talking about, but that is a mole. What do you think he is? He's a digger. Look at the big nails. Okay? Now, I'm going to show you pretty soon here, I'm going to show you a little poster about the mole, but people have labeled the mole as a chemist's dozen. Okay? A chemist's dozen. Just like bakery and baking. You don't go to the bakery and say, hey, give me 24 donuts, do you? What do you say? You go, give me 2 dozen donuts. Okay? Could you tell me what 1.5 dozen were? Right? You could. Okay? You could. That's what we're talking about, the chemist's dozen. Because as a dozen is to donuts, a mole is to atoms. Okay? So, we went through that. Now, let me show you this Avogadro's number. Okay? Avogadro's number. The number of particles in a mole has been determined. And that number is right there, the best modern value, 6.0221367 times 10 to the 23rd. Is that a big number or a small number? That's a really, really, really big number. All right? So, the number of particles in 1 mole is that many right there. So that's a bunch of particles. Now, why is this thing called Avogadro's number? Okay. Why is it Avogadro's number? Because it came from, let me get this pulled up here. Not there. Where we at? Where we at? Come on. Not there. I just put it on there. Where is it? I don't see it. So, I guess I got to call it up. Let's see if this will work here. All right. Now, on my poster here, it's not working right here. What happens if I exit out of it? I don't know. Give me a second here. Okay, looking at this little poster, I get on a little Pinterest thing. I got this off of Pinterest because I have the chemistry stuff. The mole, 6.022 times 10 to the 23rd. This good-looking guy right there is Avogadro. Okay? I believe it's a medio. It's a medio. Medio Avogadro. Okay? That's a picture of him right there. Now, the mole. Okay? If I go down here a little bit, you can see right here that the mole is essentially this number right there. That's putting all of the zeros into it. So, it is a very, very, very big number. That many particles. Okay? That many atoms, that many molecules, that many formula units. We've talked about those before. We're going to talk about them again. Okay? So if you look, that if I had, right here, if I had 1 mole of water, okay, it would have this many water molecules in it. Okay? That's a lot. Okay? So 1 mole is Avogadro's number, no matter what you label it. 1 mole of water would have Avogadro's number of molecules. Why did I say molecules? Well, how is water bonded? Okay? How's water bonded? Anyone? Anyone? Okay? Covalently. Okay? Covalently. Now, here is iron. Right here is iron. So, if I had 1 mole of iron, I would have Avogadro's number of atoms, because it is a single element. Here is table salt, sodium chloride. How is sodium chloride bonded? Ionically. So we would call that a formula unit, right? So 1 mole of sodium chloride would have Avogadro's number of formula units. All right? So I wanted to show you how big the Avogadro's number actually was. Now, moving on. How does it relate? 1 mole of carbon has Avogadro's number of atoms, and it will weigh 12 grams. Okay? Look at carbon on your periodic table. What's the atomic weight of carbon on your periodic table? 12.011. Okay? Think that's a coincidence? Okay? So that is what? 12.011 is 1 mole of carbon. Not a coincidence. Okay, there we go. There's Emilio. I knew I had a picture of him. Little background. Italian scientist. Okay. Italian scientist. I just met you, and this is crazy, but here's my number. You ever heard that song? I don't even know who sings it. Carrie Underwood? Taylor Swift? I don't know. Who? Never heard of her. Okay, I've heard the song, but I've never heard of her. Okay, little bit. What is this called? A meme? Is that what this is? Okay. All right. So, little meme, I guess, about Avogadro's number. So, here we go with water. Let's relate this stuff to water. 1 molecule of water. Okay? Avogadro's number of molecules. 1 mole of water. Here is a slide. Here is a slide that just shows you 1 mole of different things. Right here, sucrose. Okay, sucrose. How is this bonded right here? Molecularly, so that's covalent bonding. So 1 mole of sucrose has Avogadro's number of molecules, and its mass would be what? Looks to me like 342.3 grams. Here's sodium chloride. We said 1 mole has Avogadro's number of formula units. Its mass is going to be 58.4. How do you think we got the mass there? Added the atomic weights. So if you look at sodium and you look at chlorine and add those two together, it should be somewhere close to 58.4. Right, you only add sodium and chlorine once. Yeah, for this one, you would have 12 carbons added in there and 11 hydrogens. So it would be a little bit more in depth. We've already talked about carbon. Huh? What did I say? Oh, 22 hydrogens. No, it's 342. Okay? You can't see the decimal. Now, right here, copper 2 sulfate. Okay? If you would add all of those masses, 1 copper, 1 sulfur, and 4 oxygens, you would come up with that number right there, 159.6. Okay? So, how we're going to use Avogadro's number is right there. 6.022 times 10 to the 23rd. So when we round using Avogadro's number, you put 6.022 times 10 to the 23rd. You ever wonder why all our web assigns are due at 6:02 a.m.? Huh? Huh? It's because of Avogadro's number. You know what time I wake up every day? Well, not every day. Every day before school? 6:02. Okay? Because of Avogadro's number. That's why